Good morning, everyone. We'll give everyone a few more minutes. Just want to make sure, can you guys let me know that you can see section 5.3 and my screen? Thank you. All right, well, it's 10:30, so anyone else who comes in, they'll just have to catch up. So how's everyone doing with your quizzes? Is everybody working on your quizzes, making progress? I hope so. Remember, we have making progress. Good, Sylvia. We have covered all the material through oh, good job, Shannon. That's great. We have covered all the material through module 11. Your module 10 quiz was due over the weekend. Your module 11 quiz is due this week. I say work on those as soon as possible. We are starting the module 12 quiz or material this week. Remember, there's only 13 modules. So we only have this week and next week for lecture. And then we're going to start looking at the final exam review. So, and we are going to be using Honor Lock again. For anyone that had a hard time with Honor Lock, please make sure you review the directions. I will be posting them again with the worksheet and the information for CamScan. I've got, for some of those that took the exam late due to other issues, you guys saw there were some updated instructions I put together just based on some of the issues we had earlier on. Again, I know it's frustrating. We're all kind of new to this this format, so I know it's not the easiest way, but we're just going to keep doing our best and make it all work. So yeah, so again, for the final, we will be using Honor Lock again. The final exam is going to be covering modules 9 through 13, and it's not cumulative, so it does not necessarily cover the previous chapters, but remember we talked about this, the information built on itself. So even though it's not specifically talking about modules 1 through 8, some of the information we learned there, we're still applying. So if you have any questions about the final exam, let me know and we can talk about it. I'm available through email. If you guys want to schedule, and I've posted it, but I don't know if everybody's seen it. If anybody wants to schedule a private Zoom meeting to go over any questions you have, I'm more than welcome to do that. I'm more than happy to do that. I do have those office hours before class, but I know not everyone's available at that time. So I'm more than happy to schedule at another time that works for both of us. You just need to reach out to me and let me know. So does anybody have any questions about anything through module 11 or anything about the final exam before we start talking about class or module 12, excuse me? Okay. Remember, if you have a question, oh, thank you, Shannon. If anybody has a question, during the lecture, just type Q in the chat and I can unmute you so you can ask your question. That way we can still have some interaction. I know I miss seeing your faces in class. I miss talking to you guys. So if you want to ask your question verbally instead of typing through chat, let me know. All right, so remember last week we started talking about decimals, adding and subtracting decimals. Everybody likes it a lot more than dealing with fractions, right? I think you guys are going to keep up that liking it more because now we're going to talk about multiplying decimals. Again, we're going to walk through how to do it manually because you guys should understand how to do it manually. But I still encourage you to always check your answer with a calculator. It's easy to check it. It's quick to check it, but I just want to make sure you guys do understand how to do this stuff if you don't have a calculator. All right, so again, last week we talked about adding and subtracting decimals. Now we're going to talk about multiplying. So because decimals can be thought of as shorthand for fractions, we can understand how to multiply decimals by looking at fraction multiplication. Again, if this is confusing, don't worry about it. This is more of the why, not necessarily the how. So this is the why things work. So here we have 2 decimal places, 0.2 times 0.3. Here we have 2/10 times 3/10. Because remember, 0.2 is the same thing as 2/10 and 0.3 is the same thing as 3/10. It just, if we were, I wish I could cover it up with my hand. If we were just looking at this part of, I wonder if I can, no, that's not going to work. If we could just look at this fraction part, this 2/10 times 3/10 and multiply across, we have 3 times 2, or 2 times 3 on the top is 6 and 10 times 10 on the bottom is 100. So when we multiply out that 6/100ths, remember that's the same thing as 0.06, and we talked about that last week. So when we have 0.06, the important thing to point out here is that you had 1 decimal place here and 1 decimal place here. That's 2 total decimal places between these 2 numbers. And our answer has 2 decimal places. That's an important thing. So however many decimal places you have in the numbers you're multiplying is how many you're going to have in your answer. So in general, multiply the numbers ignoring the decimal points, then make the number of decimal points places in the product, which is your answer, equal the total number of decimal places in the factors, which are the numbers you're multiplying. So here we have 2 and here we have 2. So here's an example where we have 4.23 times 0.7. If we were to ignore those decimals and do the long multiplication, we would get 2,961. Now we have 1, 2, 3 decimal places. So we have 1, 2, 3 decimal places. Do you guys see that? Yep, good. So much nicer, right? All right, so the process is to multiply the numbers as whole numbers, ignoring the decimal points, and then place the final decimal point so that the number of decimal places in the product or answer equals the sum of the number of decimal places in the factors or the number you're multiplying. Important notes, ignore the decimal points at first, then insert 1 in the final answer in the position where it needs to be. For some decimals, you can avoid doing the long multiplication by using mental math. That's especially, like, look at this one. We have 0.3 times 0.2. I know that 2 times 3 is 6, and I know I need 2 decimal points. So you just have to put in a 0 there to make it 2 decimal points. So what they're saying here is that we have 0.003 times 0.025. Well, I know that 3 times 25 is 75. So we know that at the end we're going to have 75, and then we need to have 1, 2, 3, 4, 5, 6 decimal places because we have 3 here and 3 here. So you start counting backwards, 1, 2, 3, 4, 5, 6. So notice you just need to put in those leading zeros until you have enough decimal places. And remember that for 2 signed numbers, if you multiply the same sign, you get a positive answer, and if you multiply different signs, you get a negative answer. Should we line them up? Joy, you're just gonna, you can line them up. When you line them up, you don't have to worry about the decimal point for multiplication. We'll go through some examples so you'll see. The only time you have to line up your decimal points when you're doing the arithmetic is when you're adding or subtracting. Then you have to line them up. When you're multiplying or dividing decimals, well, we'll talk about dividing next, actually. When you're multiplying decimals, you don't have to line them up. Just multiply them as if they're whole numbers and then put the decimal point in. Okay. All right, so let's go down here. We're on page 27 on your turn. Oh, I almost just grabbed a regular pencil to write on my tablet. That would have been. All right, let me write this and then I'll show it so you guys can see it. So we have 307, oops, and 0.6. So see here how our decimal point is not lined up. We have one decimal point here and one here, and they're not lined up, but the numbers are lined up. So if we were to do the math as if they're just whole numbers, we would say 7 times 6 is 42. Carry the 4, 6 times 0 is 0, plus 4 is 4. 6 times 3 is 18. And then I have 1, 2, 3 decimal points and 4. Again, 1, 2, 3, 4. So we 3 in the first and 1 in the second. So we go 1, 2, 3, 4. So that's your answer. Does that make more sense now that you've seen the math do it now instead of just the process typed out? Does that make sense, Joy? Fine. All right, we'll go through some more examples. It'll hopefully become clearer. So part B, we have, you know, I remember those old, was it Magnadoodle? Do you guys remember those? The Magnadoodle where you twist the knob. Some of you young people might not remember, but you twist the knob and it draws the little picture and you have to shake it out. That's what I feel like every time I erase one of these things. All right, so part B, we have negative 9.6 times negative 1.3. Wait, do kids still play with Magnadoodles? Anybody with little, like my kids didn't play with Magnadoodles. Any of your guys' kids play with Magnadoodles? Never mind. They good. I'm glad they are coming back. All right, sorry guys. So here we have 9.6 times 1.3. So the way that we're going to draw that out then is that we're going to line it up. But again, the only reason these decimals are lining up is because, playing with what, Kate? I was talking about a Magnadoodle. Does that mean you don't know what a Magnadoodle is, Kate? Crap. All right, I'm gonna either post a link so you can see what it is, or I will share it next class. I'm not Googling anything right now because God knows what'll show up. All right. So anyway, we didn't have to line up our decimal points here. The only reason these line up is because they have the same, they both have 2 digits. Okay, so like for example, if we had 9.62 times 1.3, I'm just going to show you guys. This is just an example of why it doesn't need to line up. We would write 9.62 and 1.3. The only reason this side is lined up is because the number of digits is the same. I just want to make sure that's very clear because I don't want anyone to be confused by that. All right. So here we have 6 times 3 is 18. Carry the 1. 3 times 9 is 27, plus 1 is 28. And then we go to the other side where 1 times 6 is 6 and 1 times 9 is 9. That was easy. Then we add them. We have 8, 14, carry the 1, 12. Now, how many decimal points do we have here for this problem? 2. Very good, right? We have 1 here and 1 here. So we have 2. So we go 1, 2, and the answer, oh God, see, this is terrible. Then the answer goes there because there's 2 decimal points here. There's 2 down here. All right. And then how can we check this? We can always check this on our calculator. Okay. All right. Let's do at least one more of those so you guys can see it. It's pretty similar to what we did before, but I just want to make sure. And here's the thing. If you don't remember this or you're struggling or you want to check your answer, just plug it into your calculator and check your answer. So now down here on your own, we have, and don't worry, I'm going to move the screen. I just need to write it out. All right. So we have 27.5 times 0.2. Are they both positive? Yes. All right, and in this one then, the decimal points are lined up again, but that's also because of where the number of the digits were, how many decimal places there were. So here we have 5 times 2 is 10, carry the 1, 2 times 7 is 14, plus 1 is 15, carry the 1, 2 times 2 is 4, plus 1 is 5. And again, we have 1 decimal place, 2 decimal places. So we go over here, 1, 2, and put the decimal place there. And here's another thing. Whenever you multiply a number by a fraction or a decimal that's less than 1, like this one, you're going to get a smaller number. because basically you're saying, what is 0.2, which is the same thing as 1/5. What is 1/5 of 27.5? All right, let's do one more and then we'll talk about the next subject. All right, so here we have part B. We have negative 6.2 times 8.9. Oh, these ones are gonna line up again. Oh, that's fine. So here we have 6.2. Again, I'm just gonna write it out without the negative, even though, or you can write it there just to remind yourself it's negative. So, oops, sorry. Make sure you guys can see that. So we have 2 times 9 is 18. Carry the 1. 9 times 6 is 54. Add 1, 55. And then we have 8 times 2 is 16. Carry the 1 again. 8 times 6 is 48. And we have 49. Now, again, the reason I don't write my negative here is because if I have a negative 5 something, 558 plus 496, that's a different answer. We need to add these together. 8, 11, carry the 1. We have 14, 15, carry the 1, 5. And again, we have 1, 2 decimal places, so I go over 2 here, and it's 55.18. So just always remember, however total number of decimal points you have here is how many you should have. Holy moly, that's a terrible bracket. Is however many you should have down there. That's better. Any questions about that, guys? Good. Okay. All right, let's go down. So now we're going to talk about how to estimate when multiplying decimals. So front-end estimating gives us a quick approximation to an exact answer. It's a great way to check an answer. So in this one, we're not even going to talk about commonplace estimating. Remember, we talked about that before. This is just the front-end estimating. Remember, front-end estimating is where you just look at the very first number, the most left number, and round from there. So in this example, they have, for the exact, 6.7 times 2.1, so they multiplied it out and got 14.07. The front end estimating, you look at this first digit here, we have a 6, but that 7 rounds it up to 7. So that becomes a 7. And then the 2 here, that 1 rounds it down to 2. So we keep it 2. 7 times 2 is 14, which is very close to 14.07. The process here is to round each number to its leftmost place value, multiply as indicated, and then compare the estimate to the exact answer to see if the exact answer is reasonable. And remember, I've been saying this since day one. And this is just in general. Always make sure your answer makes sense. If your front-end estimate gives you 14, but your actual multiplication gave you 140, you probably just messed up with your decimal points. All right, so your decimal places. So always check and make sure your answer makes sense. Just a little reality check. Important notes, estimating can be used as a quick estimate without doing exact calculations or as a check for how reasonable an exact calculation is. Commonplace value estimating isn't as helpful here as when adding or subtracting because it often can't be done quickly. Again, the whole idea of estimating is to do something quickly. If it makes it more difficult or it doesn't make sense and it's not really helping you, right? So in this case, commonplace value estimating is a pain because you'd have to line up your numbers, whereas we don't have to do that for multiplication. All right, estimating can be done with positive and or negative numbers. Remember that for 2 sign numbers, when you multiply the same sign, you get a positive answer. When you multiply different signs, you get a negative answer. If the exact answer is close to the estimate, the answer is reasonable. Note that estimating sometimes gives a very rough approximation, so consider the estimate and exact answer as close unless they differ greatly. Again, there's no like specific, oh, these are so different or these are so close, but you do need to use a little bit of logic in that step. The larger the difference between rounded numbers and their originals, the less accurate the estimate is. And that's a very important fact. If, let's say you have all your numbers are at 0.5 or you're rounding up 10, almost 10 or something like that, or if you're rounding to the hundreds place, the more off your number is from the exact number, your rounded number is from the exact number, the more off your estimate's going to be. You need to take that into account when you think about how close or reasonably close they are. If both numbers round up, expect the estimate to be larger than exact, and if both numbers round down, expect the estimate to be smaller than exact. That's pretty logical. So that should be pretty clear. All right, notice I don't have highlighting here. I've had some really weird issues with trying to highlight to make sure we're hitting all the points. So Now you get red X's, just for this part though. All right, so we're on your turn 2, which is on page 29. Multiply 19.1 times 2.5, then check whether the exact answer is reasonable by using front-end estimating. So first we're going to do exact, and then we're going to do the estimate. So let me just write this out real quick. 19.1 times 2.5. All right. So first we're going to do exact. That's fine. So we have 19.1 times 2.5. So here we have 5. 45, carry the 4, that's 9. We have 2, 18, carry the 1, and that gives us 3. So let's add them up. And in the meantime, can you guys all tell me how many decimal points my answer should have? 2, very good. There's 2 in the problem, there's 2 in the product, the factors, and then there's going to be 2 in the final product. So our exact answer is 47.75. So now if I'm going to do front-end estimating, what numbers am I going to multiply? Can anybody tell me what my first number is going to round to? Remember, we have 19.1. What does that round to for front-end estimating? 19. Now remember, this is our front number. So we go to our very front number, and then we look to the number right to the right of it. 20. There you go. Very good. So don't round just to the decimal points. Remember, when we do front-end estimating, we look to the very front number. So this is going to round to 20, and then we have 2.5. Good Lord, 2.5. All right, so what's that going to round to? 3. Very good. We start here at the front number, and we look to the number to the right. That 5 rounds it up to 3. Now let me ask this, before we do out the math, does anybody know if our estimate's going to be higher or lower than our exact? I wish I could cover this up with my hand so you don't see it. Remember, we rounded both of these numbers up. So does that mean our estimate's going to be higher or lower than our exact? Lower. Well, think about it this way. We rounded both numbers up. So now we're multiplying 2 higher numbers than we multiplied before. Yes, higher. Very good. So let's go ahead and multiply it out. We have 0 and 6. So our front end estimating is 60 and our exact is 47.75. But look, we rounded this one up pretty high and we rounded this one up. Do you guys think that those are still reasonably close? I would think so, because here we already are adding up an extra half of 20. So yeah, that's still reasonably close given that we rounded both of them up. That's important to note, and it's important to look at that and go, oh, wow, that's why that's so much higher. All right, let's move on. Let's check another one. So let's go down onto on your own, part B. And we have -4 times 32.05. Again, we're going to do the exact and then front end estimating. So for the exact, I'm actually going to write this number first because it's the longer number, and I always like having that longer number on top. That's the proper form, times 4. And I'm just going to write a negative out here, but I'm not going to write it until the very end for my answer. So again, notice there's no decimal places in the second number, and it lines up with that hundredths place, right? Again, we don't line up for the decimals when multiplying. So here we have 4 times 5 is 20, carry the 2, 4 times 0, 0, 2, 8, oops, that's a terrible 8. 8, and then 12. Is that right? 8, 12, yeah. All right, and then we have 2 decimal points here, so we have 2 here because there's none in the second one. So our answer is 128.2, and it's negative because that was negative. All right, so now we're going to do our front end estimating. So how would we round 32.05? What would that round to? Any ideas? 32? Not 32, sorry. Remember, we look at the front number and then look to the number right to the right. 30, very good. There you go. So this would round to 30. And then we have -4. We don't have to do anything with that, right? It's already rounded to its front end because there's only one number. So when we multiply those, we get 120, and it's negative. And that's very close to that -128. So that tells us, did you see, Shannon? It actually rounds to 30, not 32. Do you see why? I don't know if anybody's delayed on the video, but it's because we look to that number and we look there. We don't round to the decimal, we round to the very front leftmost place. So in that case, it's the tens place. All right, and those numbers are very close. All right, guys, make sure that's all clear. All right, let's do one more of those just to make sure. So we're on part C. We have 76.4 and 15.1. So we're gonna do our exact 76.4 and 15.1. So let's go and do the multiplication. This one's gonna be kind of long. I'll write small. 4, 6, 7, right? Because they're all multiplied by 1. And then we have 20. 5 times 6 is 30. Is 30 plus 2 is 32. 5, and then we carry a 3. We have 5 times 7 is 35, 38. And we have another 1. So we're going to be 4, 6, 7. All right, and then we have to add that up. So we have 4, 6, 7, 9, 13. Carry the 1. 15, carry the 1. What is that, 11? I'm running out of space over here. And only 2 decimal points, right? Because we have 1, 2. So we have 1, 2. So the exact answer we got is 1,153.64. Do we always have to do front end for each problem, Sylvia? That's a good question. You will do it when it says to do it. If it doesn't say you don't say to do it, you don't have to. But in this case, the instructions are telling us to do it. And you don't have to do it. I do recommend doing it, even if you just do it mentally, just so you know that you're in the right place. And you will have to do them on some of the quiz problems. All right, so does that answer your question, Sylvia? Yes, good, okay. All right, so let's do our front end estimation. So we have 76.4. Does anybody know what that would round to? Remember, go to your leftmost place. Don't round at the decimal point. Go to the leftmost place and tell me what it would round to. 80, very good. We look at the 7, go to the number to the left, that rounds it up to 80. And then what about the 15.1? What would that round to? 20, very good, again. 20. Now, you're gonna see this in the next little section about how to multiply numbers with zeros at the end. But I will tell you right now that this is gonna be 1,600 when you multiply it out. Wow, that's a lot higher, isn't it? But look, we rounded this all the way from 76 to 80, and we rounded this all the way from 15 to 20. So we rounded up pretty high. But that means that these are still close. They have the same number of places. So here, this is a thousands place. This is also in the thousands place. So it makes sense, and it's reasonably close. Does anybody have any questions about how to multiply decimals and front end estimating? Not yet. Good. That's a good sign. Okay. All right, so let's go down. Now we're going to multiply decimals by powers of 10. And this is what I was just talking about. It's actually kind of helpful. So here are a couple of shortcuts to use when multiplying decimals. But no, don't worry about it. This is actually easy. And if you don't remember it, it's okay. So don't worry. Here are a couple of shortcuts to use when multiplying decimals by powers of 10. Again, this is a shortcut. If you don't remember this, just do the math out. This is, again, one of those things, if it makes sense to you and it helps you, use it. If not, don't worry about it. It's very helpful though. I promise, if you can just take a quick look at it, it's not bad. So Powers of 10 include 10, 100, 1,000, and they can also be less than 1, such as 0.1, 0.01, 0.001. These are all powers of 10. When multiplying by 10, 100, 1,000, so that's the tens on the greater than 1 side, move the decimal point to the right the same number of places as there are zeros and powers of 10. So here we have 51.3984 times 10. All you have to do is move that decimal over 1 place to the right, and your answer is 513.984. Here we have the same number, 51.3984 times 100. So now we're going to move it from here over 2 decimal places. Get it? 2 zeros, move it 2 decimal places. So now the answer is 5,139.84. Here we have the exact same number, 51.3984 times 1,000. Now we have 3 zeros. So we go over 1, 2, 3 decimal places to the right. So now that's the answer is 51,398.4. So all you're doing is moving it from where it started over to the right, the same number of decimals as there are zeros. Now, when multiplying by 0.1, 0.01, 0.001, move the decimal point to the left the same number of places as there are decimal places in the power of 10. Now, again, if this doesn't make sense, this is just a shortcut. So here we're starting with the same number, 51.3984, and we're multiplying it by 0.1. There's 1 decimal place. We're not just counting zeros, we're counting decimal places. We're going to move it from that 51 to the left 1 decimal place. So now the answer is 5.13984. Now we're going to multiply by 0.01. We have 2 decimal places. We only have 1 0, but 2 decimal places. So we're going to move it from the 51 spot, right in between the 1 and 3, to the left 2 spots. So now the answer is 0.513984. This last one is multiplying that number by 0.001. So now we have 1, 2, 3 decimal places. So we're going to move it over 3 decimal places to the left. And notice they had to add in a leading 0 to make sure we had 3 full decimal places moved over. So that answer is 0.0513984. If this does not make sense or you find it more confusing, that's okay. Well, it's not okay. I'd rather you understand it because it is a nice little handy shortcut. But if you don't, do out the math. It's okay. It's just a shortcut. So the process is when you're multiplying by 10, 100, 1,000, etc., count the number of zeros in the power of 10 and then move the decimal point to the right the same number of decimal places as there are zeros in the power of 10. Again, this only works if you have that number 1. If it's 10, 100, 1,000, etc., or 0.1, 0.01, 0.001, etc. This does not work if you have other numbers. It does, but it's a little more complicated. So don't worry about it for that. So multiplying by 0.1, 0.01, 0.001, etc., count the number of decimal places in that power of 10, and then move the decimal point to the left the same number of places as there are decimal places in that power of 10. So it might seem strange that a power of 10 can be less than 1, such as 0.1. We'll see in a later chapter. We're not going to cover that in this class, but it has to do with 10 to a negative power. But again, we're not going to worry about that in this class. All right, to move the decimal point to the desired number of places, you might need to put filler or ending zeros at either the front end of the either the front or end of the number. So make sure you count your places and add zeros when you need to. If you forget a shortcut, you can always multiply the long way, which is what I was just saying. And sometimes large power of 10 numbers are written with a mixture of numbers and words. To write these numbers in standard form, multiply the number part by the power of 10 that the word part indicates. We're going to go through this, but basically saying if you have 7.2 million, that's the same thing as 7.2 times a million. And if you multiply it out, that's what you get. Again, we'll do an example like that because that is going to be on the quiz. So we're on page 31. Let's go down to your turn. So here we have part A is, yes, Joy, you do need to remember between left and right. And you also need to remember if you're counting zeros or counting decimal places. Remember, if the number's 10 or above, you're counting zeros. If it's less than 1, which means you're at the decimal part, you're counting decimal places, not just zeros. So negative 0.567 times 100. So we have, this one is bigger than 10, right? So we're gonna count the number of zeros. We have 2 zeros. So that means we're gonna be moving that decimal point to the right 2 places. So this is gonna equal negative 56.7. Okay, let's look at part B. We have 89.8 times 0.0001. Is that right? 1, 2, 3, 1, 2, 3. Okay. So here we're now less than 1. So we're looking at decimals. So we're counting decimal places, not just the zeros. So we have 1, 2, 3, 4. So that means we need to move this over 4 places. So that's going to equal 89. But I'm going to just, well, I'm not going to write the point there. I'm going to put it where it was. We have 8, and we need to move over 1, 2, 3, 4. So we need to put those zeros in. Right? 1, 2, 3, 4. So now we have this. Oh, you know what, guys? I'm sorry. Shoot, I thought we were, ugh, don't listen to me. Ignore me for that one. Let me just start this one over. I'm sorry. Ah, Lord. All right, so we have 1, 2, 3, 4. So we need to move this over this way 4 decimal places. I'm sorry about that, guys. Of course, I'm confusing you. All right, so we're going to write 0.00898. Remember, we started here and we had to go 1, 2, 3, 4 places. So we had to add in those 2 leading zeros. Okay. Remember this, if you're multiplying by a number less than 1, like this, you should get a smaller number in your answer than you started with. If you're multiplying by a number bigger than 1, like this 100, you should get a number bigger than what you started with. Okay. All right, and then let's do one, and we're gonna do, actually, let's go ahead and do, let's go down to the on your own to go through a few more of those in that form, and then we'll go back to that word form one. So let's go to on your own part B, and we have 305.6 times 0.1. So let's ask this, should that answer be bigger or smaller than my first number I'm starting with? So should my answer be bigger or smaller than that number? Smaller, very good. So which way am I moving the decimals? To the left or to the right? To the right? That's going to give me a bigger number. Whenever you have decimals, you're moving to the left. So here we have 1 decimal place. So that means we need to move this 1 decimal place over. So that means we're going to get 30.56. So we started here and we moved it over 1. If we had moved it over the other way and had our decimal over here, we would end up with a bigger number. That's another way that you can check. That's all right. It's okay. Yeah, and that's how you know too. That's why I want to make sure you guys understand what number you should end up with, a bigger or smaller number, because if you do it the wrong way, you'll go, oh, that number is bigger. I should have a smaller number. I should go the other way. All right, so let's look at that on your own part C, 0.809 times 1,000. Should my number be bigger or smaller than what I'm starting with? Bigger. Very good. I'm multiplying by 1,000. I should certainly get bigger. So does that mean I'm moving the decimal to the left or to the right? Right. Very good, Sarah. To the right. Because if we moved it to the left, we'd end up with a small, ooh, that's not what I want, a smaller number. So when we're on the bigger number than 1, right? We're at 10, 100, that side of it. We're not less than 1 in a decimal. Are we counting zeros or are we counting the number places? Zeros, very good. So remember, we're going to count, we have 3 zeros. So that means we need to move to the right 1, 2, 3 places. So that's going to give us 809. Does that make sense? Yes, good. Now, again, if you have a hard time with this shortcut, that's okay because you can always just do the math out, okay? Okay. So let's go ahead and delete this. And let's look at this word problem on your turn 4. So we have multiplied by a power of 10 to write 1.7 million in standard form. So remember, we just looked at this in examples really quick. So when we're doing that, let me see if I can keep it up here at the same time. So we're going to multiply by a power of 10 to write 1.7 million. So we're going to start by writing 1.7 times a million, right? So we have 1, 2, 3, 1, 2, 3. Is that right for my million? So when they say that, you have 1.7 million, that's what this is saying. It's saying 1.7 times a million. All right, so then this one's clearly bigger than 10, this number that this product that we're multiplying by. So we need to count our zeros. So we have 1, 2, 3, 4, 5, 6 zeros. So that means we need to move this over 6 places. So we're starting at 1.7 and we need to move over 6. So we have 1, this is the first place, 1, 2, 3, 4, 5, 6, right? So that means that we can go 1, 2, 3, 4, 5, 6. So we can erase this part now, and now we need to put in our commas. We remember 1, 2, 3, comma, 1, 2, 3. And we all know, and this is why this one's kind of handy, we all know that this is, oops, sorry, this needs to be a little lower, right? We all know that when we read 1.7 million, this is what we're looking at, right? But this is why this is 1.7 million, because it's the same thing as 1.7 times a million. Does that make sense? Kinda. Do you want to see one more word example like that? I can do one more. All right, let's look at this other one. Oops. It's kind of, let me see if I can cue it up. There we go. So we have multiplied by a power of 10 to write 6.3 billion in standard form. So we would start by writing 6.3 times 1 billion. And it even tells us here what 1 billion is, but we know, right? 1, 2, 3, 1, 2, 3, 1, 2, 3. That's a lot of zeros, right? So we have to do 9 decimal points. So that means if we start here with 6.3, we need to count 1, 2, 3, 4, 5, 6, 7, 8, 9, right? That's how many we should have total. And then we go back and put our commas in. Okay, so 6.3 billion. All right, so what I would do if I were doing these, I would write it out just like this, and then I would write it a second time, because like I said, these are going to be in the quiz. I would write it a second time, write 6.3, and then just count. So you start here 1, 2, 3, 4, 5, 6, 7, 8, 9. And then you can just erase your decimal and go back and put your commas. Okay? All right, everyone okay with that? Doing okay so far with the multiplying of decimals? All right, let me give you guys, good, I'm glad, oops, that's not the right spreadsheet. Shoot. Let me, is that maybe that, nope. There we go, practice problems, sorry. All right, so there's the practice problems right here for 5.3. We have 7, 9, 13, 15, 31, 33, 37, 41, 45, 49, and 51. Now, we do have a little extra time today, and I'm going to go ahead and start covering section 5.4 for Module 12. The reason for that is For module 13 next week, it's covering 3 sections. They're not like terribly time consuming, but I want to make sure we leave room to get through that. And hold on real quick, Sarah. I'll just address that really quick in just 1 second. I want to make sure that we have enough time to do exam review. And if we can have 2 days of exam review where like you guys can just ask a bunch of questions, I think that would be beneficial to you guys. So if we can get through all the material a little sooner and you guys can start working on your module 12 and 13 quiz, then we would have more time for like Q&A for the final exam. Okay, so Sarah, let me get back to yours. When I have a question when writing in standard form, when they say negative 827 thousandths, what would that be if there is no and? Negative 827 thousandths? Well, there's no, okay, good question. So if there's no and, that just means, let me read it again, sorry. I'm like a little computer screen up. When they say negative 827 thousandths, that means that there's no whole number part of that number. So negative 827 thousandths would be 827. Oops, or I could write 72. So if it doesn't have an and in it, that means that there's no whole number part. Because the thousandths, when they write thousandths like that, I don't know if you guys are all following on the chat, but Sarah's asking what it would mean when they say negative 827 thousandths. When there's no and, it means it's either that or, but I would not say hundredths, because this is the thousandth place. You have tenths, hundredths, thousandths. So if that part's tripping you up, go back to section 5.1. There's a little table. There's a little, you guys probably always see my reminders for my kids. There's a little table that shows the different decimal place names. So it goes tenths, hundredths, thousandths, 10 thousandths, 100 thousandths. We don't have a ones place with decimals. It is. And you wrote right here, you did write 20, you wrote 27 thousandths with a THS. Oh, I see what you're saying. Okay, I see what you're saying. Okay, I'm gonna have to bring this over because I wanna make sure I'm highlighting the part you're saying. Okay, can you guys see the chat on the window now? Sorry. I see what you're saying now. So when they say this, 12. Well, your quiz number 12 is gonna be different than other people's. I can look at yours, but listen, really quick. So when this says 827, what you do when you see that is you just go ahead and write 827, right? You already know it's negative. And then that tells you whatever the number part is. This tells you the place. So that tells you that it's a decimal. But the number itself, the whole number part's not the whole number part, but the number itself that's after the decimal is 827. Does that make sense now? This is the place where it tells you where the decimal is. Perfect. Good. Okay. Did that help anybody else? Is anyone else having a hard time with that? I'm sure you're not the only one having a hard time with that, Sarah. All right. Okay, so I'm glad that is clarified. Any other questions before I move on to section 5.4? Okay. All right, we're probably not going to be able to get through the whole thing, but we're going to get through at least some of it. I was having a really hard time. So I'm working in a PDF for the textbook, and I'm having a really hard time with it. Stopped letting me highlight some of the stuff. So if we get past that, that's fine with me. Do you guys find that highlighting this helps you guys or not? If it's not helpful, I won't worry about it, but I always thought it was helpful. It does help. Okay. I always thought it was helpful to show you guys what parts we're going through. All right, so now that we've talked about multiplying decimals, now we're going to talk about dividing decimals, or how to divide decimals. For the decimal division, we will use the same long division format we used for whole numbers. The only difference is that when dividing decimals, we must be careful how we position the decimals as a reminder. We have This is the names of everything. So the dividend is the number that you're starting with. That's the number out here, that 8.66. It's okay, Joy, don't worry, it's fine. You can always check in your calculator. So that 8.66, that's your dividend right here. That's what's gonna go inside. And then you have your divisor, that's what you're dividing by. In this problem, it'd be the 2. Then your quotient is the answer at the end. And this one is the number on top. So here's how we divide. It's really not that bad, I promise. Dividing a decimal by a whole number. So here we have 8.6 divided by 2. What you do is you put your 8.6 in the inside like we normally do, and the 2 on the outside. Then you bring your decimal and you write it the exact same place on top where your quotient or your answer is going to go. And then you just divide as if nothing else has changed from long division. You just make sure that that decimal lines up. Now, dividing a decimal by a decimal, it's very similar. You just have to take one extra step before. So here we have 8.66 divided by 0.2. So you write it the same way. You have 0.2 divided by 8.6, or 8.66 divided by 0.2. But before starting your long division, what you do is you move your decimal place over one spot right here so that you have a whole number. But whatever you do in here, you have to do inside here too. So basically, what I wish I could show you guys with my hands the way I normally do, but we have this 0.2 becomes a 2, and this 8.66 becomes 86.6, and then you can rewrite it right here if you need to. The reason for that is, the reason we can do that is the same reason for fractions, that we can simplify fractions, right? It's a division bar. Whatever you do to the top, you do to the bottom, and vice versa. So here, basically, remember, division is a fraction, or fraction is another way of writing division. So we're just doing whatever's on the outside, we have to do to the inside, okay? And then, again, you line up your decimal on top, and then you just divide as if we did before with long division. And we'll go through some examples, so don't worry. So process, if necessary, move the decimal point in the divisor to make the divisor a whole number. That's the most important part, is to make sure whatever number you have out here, your divisor, is a whole number. If you move the decimal point in the divisor, move the decimal point in the dividend, that's the number that you're dividing into, the right number of, to the right, the same number of places. Place a decimal point in the quotient position directly above the dividend's decimal. Divide as though the numbers are whole numbers. Important notes: to round a quotient to a particular decimal place, and this is actually important because this should come up in the quiz. To round a quotient to a particular decimal place, carry the division to one place beyond the rounding place. For example, if you're asking for the answer to the nearest hundredth, find the quotient to the thousandths place, then round to the hundredths place. Here's an example. So let's say you wanted it to the hundredths and you had to go all the way out to 5.6677, then you round to 5.68. You need to make sure to go one decimal beyond where you need to round it so that you know if you need to round up or down. Check your answer by multiplication. So remember, the dividend divided by the divisor is the quotient. So that means the quotient times the divisor equals the dividend. So always go backwards to make sure it works. In this example, we have 10 divided by 2 equals 5 is correct because 5 times 2 is 10. When checking, be sure to use the numbers in the original problem and not the ones in the long division, which might have shifted decimals. So it's the same thing with algebra. Remember, I always said before, don't check somewhere in the middle. You always have to go back to the original. Same thing with the division here. When you're checking it, make sure you use the numbers in the original problem so that you didn't shift your decimals incorrectly. Some fractions convert to non-terminating decimals that repeat. So example, 2 divided by 3 is 0.666666666, or 0.6 with a bar over it. Remember that for two sign numbers, dividing same signs results as a positive quotient, and dividing different signs results in a negative quotient. So let's go through an example on our own. We have number on page 37 here. Let me write it down. We have negative 237.25 over 13. So remember, fraction is division. So this is the same thing as 13 dividing into negative 237.25. And we're just going to write a negative up there. Do I need to move any of my decimals? Does anybody know? Just to start. No, very good, Sarah. Why don't I need to move any decimals? The reason we don't need to move it is because 13 is a whole number. If 13 was if there was a decimal on the outside, then we would have to move. So in this case, we're just going to proceed. We're going to put our decimal up here at the top, and we're going to proceed as if it's a whole number. So 13 goes into 23 one time. We have 10 left over. Bring that 7 down. How many times does that go in? That goes in 8 times. So 13, I know this is silly that I'm using calculators, 104. But it is important that you guys understand how this all works. It gives us 3. We have 2 left over. That goes in 2 times, right? Gives us 26. That gives us 6, 5. 13 goes in 5 times. Now, did it say how far out? It says round to the nearest hundredth. Now, this is important. That means we need to go to the thousands place. However, in this case, it ends up exactly at the hundreds place. So we don't need to go any further. There's nothing left to divide into since it divided evenly. Now, if it didn't divide evenly, let's say there was a remainder down here, then we would have needed to go one more place so that we had the thousands place to know how to round the hundreds place. So this answer is negative 18.25. Now to check that, negative 18.25 times 13 equals negative 237.25 exactly. So that means our answer is correct. All right, let's do another example. Here we have part B. We have 1.25 divided into 10.375. Do I need to move any decimals here? Yes, exactly. Because this is not a whole number, right? We need to have a whole number out here. We need to move these over 2 places, which means we need to move these over 2 places. So that's going to give us now, our new problem is 125 into 1037.5. This is the same problem though, and I want to make sure that's very clear. If you think about it this way, it's because they're similar to equivalent, remember equivalent fractions, it's the same idea. Because we're doing it to one, or doing it to both, it's okay. It's like multiplying them both by 100. All right, so let's go ahead and put that in. So we have, first we have 1037 divided into 125. So that goes in 8 times, right? So we have 125 times 8 is 1,000. And that's going to give us 37. We're going to bring down that 5. Oops, 375. And that goes, of course, that goes in evenly. That goes in evenly as well. Remember, I forgot to put my decimal place. We've got to keep that decimal place there. So 3 times 125 is 375. Again, we don't need to go any further. It says here, round to the nearest hundredth if necessary. So in both of these cases, we didn't have to go any further. So we ended up getting 8.3. So let's now multiply 8.3 times 1.25, not 125. We have to use our original numbers, 1.25, and we get, oops, I divided by accident. We get 10.375 exactly. So that tells us this answer is correct. If I had multiplied it by 125 to see if it equaled this number, it may not have pointed to me making a mistake in this step. So it's important to use the original numbers. All right, let's go down some more examples. We're on page 37 still, down in your turn. So here we have 0.11. Oops, let me do this a little, well, no, that's okay. 0.11 into 7.07. All right, do I need to move the decimal places here? Yes, yes, very good, guys. We need to move it over to, oh, geez, sorry, guys. I'm hitting buttons here. Tube spaces. So that's going to give us 11 now into 707, right? Now, remember, again, we still need to round to the nearest hundredth when necessary. So let's keep that in mind, that if we need to keep going, we will. So first we have 70, 11 goes into 76 times. We get 66 with 4. Carry down the 7. So then we're going to have 11 goes into 47 4 times. That gives us 44. Oh, so now we have to keep going, right? We're going to just draw out a couple zeros just to keep our place, and we're going to put our decimal right up there. So now we have 3 left over. We're going to bring that 0 down. 11 goes into 32 times. We have 22 with 8 left over. We're going to bring that 0 down. How many times 11 go into 80? That goes in 7 times. Am I done? Because I had only to go to the hundredths place. Am I done here? Does anybody know if I'm done here? Because remember, I had to go to my hundredths place. Am I done? Well, no, because what if I end up with a 5 over here? I still have some numbers left, right? What if I end up with a 5 and that number should actually round up to 0.28? We don't know. So we need to keep going. Unfortunately, I'm running out of room, but let's go ahead. So we have this went in 77 times. So I'm going to carry right here. We have 77 with 3 left over. That 0 is going to come down here. 11 goes into 32 times. So now I'm done. But now I know that it rounds to 64.27. What's important to note is that if I had gotten a 5 or higher here, this would have rounded up. So it's really important to keep going out. So whenever it says round to the hundredths place, unless it stops there on its own, and that means no remainder, you need to go all the way out to the thousandths place to make sure you know how to round it. Okay? All right, let's do a couple more. So here we're on your own. We have part B. So we have negative 25.12 over 0.8. So how do I start this? I need to write it into long division, right? So let's start by writing it into long division. Let's start up here. We have this equals 0.8 into 25.12. Now we know we have a negative here, so we know the answer is going to be negative. Do I need to move the decimal? With no remainder, do you put 0? I'm not sure I understand what part you mean no remainder, do you put 0? You just have to make sure it goes out to the hundredths place. So if you need to add a 0 to go to the hundredths place to show that it's rounded that far, yeah, you can do that. Does that make sense? Does that answer your question? Okay, good. All right. So we need to start by moving this over 1 decimal, right? So now we have 8 goes into 251.2. Gosh darn it. And the answer is going to be negative. Remember that, because we started with a negative here. All right, so now I'm just going to go do the division, and we're going to see this one's also said to round to the nearest hundredth if necessary. So let's see where we need to go. 8 goes into 25 3 times. We get 24 with 1 left over. Bring that 1 down. 8 goes into 11 1 time. Write our decimal. I should have put that there in the beginning. Sorry, I will admit to being very bad about that. I usually do it as I'm working. You should do it in the very beginning, and I'll try to be better with that to make sure you don't lose your decimal place. So this gives us 8 with the 3, and we bring that 2 down. 8 goes into 32 4 times even. So we don't need to go any further because there was no more remainder. Now, if it did keep going, we would need to go out to the thousandths place to make sure we rounded the hundredths place. So our answer here is negative 31.4 or negative 31.40. Either way. All right, let's do the next one. We have 0.15, and then 1.35196. And we need to move our decimal point over 2 places, right? So now we have 15, and we have 135.196. I'm pretty sure we're gonna have to go out to the thousands place just because this one looks kind of messy. So let's start with our math here. So 15 goes into 135 actually 9 times exactly, which is kind of ironic. All right, so we end up with 0. Put my decimal point there, sorry guys. So then we bring down our 1. Does 15 go into 1 at all? No, so we put a 0 up here. Then we bring down our 9. 15 goes into 19 1 time. With 4 left over, we bring down our 6 because we got to keep going, right? We don't know if we're not done yet. 15 goes into 46. How many times? Goes in 3 times. And we can stop there because it said around to the nearest 100. So we don't even care what happens next. We could keep going, but we don't care. It just doesn't matter to us. So now we know we need to round to this place, and that 3 tells us that it rounds down to 9.01. Okay? Again, you can check this in your calculator. So please utilize that tool. Don't let this be what trips you up. Make sure you're always checking this in your calculator. All right, let's keep going. So estimate the answer when dividing decimals. This is actually, I hope, for you guys, an easier way to estimate. I know the front-end estimating always in the commonplace kind of drove you guys nuts. In this example here, we will again use front-end estimate as a quick approximation to an exact answer. However, you'll see in a minute why that's not always the best. So in this example, we have 87.2 divided by 87.2 divided by 3.2. 87 for front-end estimating rounds up to 90. Front-end estimating gives us 3 here, so we have 90 divided by 3 equals approximately 30. Now, if you did the exact answer, you would see it was 27.25, and it's very close. But with division, front-end estimating sometimes gives us numbers that are difficult to work with. Remember, the whole idea of front-end estimating or any kind of estimating is to come up with a quick estimate to know if your numbers are close. But however, in division, you could end up with numbers that are not easy to divide and give you some kind of messy work, and that's not what we're trying to do at all. So in this case, we'll use a method we call convenient number estimating. Here's an example where front-end estimating does not work well. 87.2 divided by 4.2. If we were to do front-end estimating, when we were to round, we would get 90 divided by 4, which does not divide evenly, and it's not really that intuitive. Convenient number estimating would be round the numbers to values that divide easily. Well, this is pretty close to 88, and this is close to 4, and 80 divided by 4 is easily 22. I can do that in my head. So the idea is to find a number that's pretty close to the exact numbers that's easy for you to estimate with. It's not an exact science in this case, because what might be easy for me might not be easy for somebody else, or what might be easy for one of you might not be easy for somebody else in the class. So this is not one of those where there's an exact answer. It's just for convenience sake. So the process for front-end estimating hasn't changed. You round each number to its leftmost place value, divide as indicated, and then compare the estimate to the exact answer to see if the exact answer is reasonable. Convenient number estimating is where you round the numbers to values that divide easily. Divide as indicated. Compare the estimate to the exact answer to see if the exact answer is reasonable. One thing that we're going to talk, well, I think they talk about it, so I'll leave it for that. Important notes. These estimating methods can be used as either a quick estimate without doing exact calculations, or as a check for how reasonable an exact calculation is. In the main idea example for convenient number estimating, changing 87.2 to 88 isn't true rounding. True rounding would give 87, but changing 87.2 to 88 is reasonable and convenient, letting us divide by 4 with mental math. So again, it doesn't have to follow like a precise process. It just needs to be something that's convenient for you. Convenient number estimating can give different estimates for the same problem because it depends on the numbers you choose to round, which I've already mentioned a few times. A good general rule of thumb is to use front-end estimating first, and then if those numbers are hard to work with, then go to convenient number estimating instead. Note that estimating sometimes gives a very rough approximation, so consider the estimate and the exact answer as close unless they differ greatly. We will not use common place value estimating for division because it often is horrific. It's ugly math. Estimating can be done with positive and or negative numbers. And remember, when you divide the same signs, you get a positive answer. When you divide different signs, you get a negative answer. So let's take a look at this on your turn 3 on page 40. So divide, round the number to the nearest hundredth if necessary, then check whether the exact answer is reasonable by using front-end estimating and convenient number estimating. So in A, let's go ahead with 162.24 divided by 5.2. So we're going to do exact. And we're going to say, remember, we already know that we're going to need to move this over 1 and this over 1, right? We just did that. So we're going to do 52 divided into 1622.4. And I'm going to remember to write my decimal point up there first. All right, so we need to start with 162, right? Divide that by 52. And it goes in 3 times. So 3 times 52 is 156. When we subtract those, we get 6, bring down our 2. 52 goes into 62 1 time. Bring that down, we get 10. Bring down that 4. How many times does 52 go into 1 and 4? Oh, that's so nice. It goes in twice exactly. Now, we don't need to keep going because there's no remainder, right? We end up with a 0 here. So we're done for the exact part. So the exact answer is 31.2. Now let's take a quick look at front end and see what that gives us. If I were to look at front end, remember we start here and we start here. So front end for this one would give me 200, right? Because we would have, does everybody see how that's 200 from the 162? Because I start with that first number and I look to the number right to the right, and whatever that is, it rounds it up or down. Then we need to do front end estimating here, where it gives us 200 divided by 5, which equals 40. That one actually isn't bad. Does it say to do front end and convenient? So that's the front end. Front end actually worked out nicely. You wouldn't have to do convenient. I think they want us just to do convenient to practice. So let's do convenient. Convenient. We'll just write COV there. All right. If I were to do convenient on that, what would you guys say? We have 162 divided by 5. Any suggestions for convenient numbers to divide there? What about like 150? 150, I would do 150 divided by 5. Because 150 is easy for me to divide, and 160 is very close to 150, and 150 divided by 5 gives me 30. Do you guys see that? Again, it does not an exact science. It's whatever's convenient for you. But to me, 162 is close to 150 and 5.2 is close to 5. So that's convenient for me. And that number actually ends up being closer because I'm not rounding as far away. 160, you could do 160. What's 160 divided by 5? Is that an easy math for you to do? Remember, it's the name's the key, convenient. To me, 150 divided by 5 is way easier to do in my head. But if 160 divided by 5 is easy for you to do in your head, that's fine. Whatever's easiest, okay? Does anybody have any questions about that one? We're going to go through some more. Let's go ahead and do part B. So we have 16.1 divided by 3.7. This one might be easier because it's smaller numbers. So let's do our exact. All right, so we're gonna have to move these over 1 decimal place, right? So we're gonna have 37 into 161. And we know that we're probably gonna have to go, I'm gonna write just 2 as a placeholder just for now, okay? Does everybody know how I got from here to here? Is everybody okay with that? Okay. I'm gonna assume that no complaining means yes. All right, So we're going to start with dividing. 161 divided by 37. The closest you're going to get is 4. What's 4 times 37? Is, oops, 148. When we subtract that, we get 13. We're going to bring down that 0. Oops. All right, and then 37 goes into 130 3 times. That gives us 111. And we have 19, bring down that 0. All right, now 37 goes into 195 times. That gives us 185. So we have 5 left over. So we have to keep going one more place, right? Because it said round to the nearest 100. So we still have to go one more place, bring down that 0. It only goes in 1 time. So now we're done because we don't care what comes after. So we would say our exact answer is 4.35. Okay, so now let's do our front end estimating. So front end, we had, oops, 16.1. That would round to 20. And we had 3.7, which would round to 4. So we have 20 divided by 4 equals 5, which is not bad at all, right? That's actually pretty convenient. So let's do our convenient number. Anybody look at that and see some numbers that look really convenient? We have, remember, we have 16.1 divided by 3.7. Can you think of any numbers that are really close to these that are convenient to add? Me personally, I look and see 16 divided by 4. That looks really easy to me. That gives me 4, which is very close to 4.35. Does anybody else see any other numbers that are more convenient to them? Maybe 15 and 3? Although you're rounding farther away, but it still is close enough and convenient. Any questions about this? I can't tell if you guys are uber bored by this or a little confused by this. Or if the chat window stopped working. One of these things has happened. Confused. What part's confusing you, Joy? Is it the convenient number? The convenient, okay. I'll tell you, is anyone else having a hard time with the convenient part? Or are you guys okay? Because if everyone else is okay, we're gonna leave off there for the day, and I can, Joy, you can stay on and I can cover that with you a little bit more. Is everyone else okay with that convenient part? All right, really quick then, let me just show you the practice problems. We have not finished covering 5.4, but for those of you that feel really comfortable, you can start working. This is for anyone that just wants to get a little bit ahead. Those are your practice problems for 5.4. I will post these when I post the video. We have 9, 11, 15, 17, 19, 73, 33, 37. I think that might be a typo in there. Oh, maybe they're just out of order. 33, 73, 37, 45, 47, 51, 55, and 63. I'm going to double check that, those list of practice problems for that 73 out of order. It might just be out of order. Anyway, if you want to start practicing and get a little bit ahead on Module 12, that you're more than welcome to it. We have not finished 5.4. We will finish that on Thursday. So if you have any questions about Module 11, Module 12, anything, but specifically this week we're Module 11 and Module 12, let me know and we'll pick up on Thursday. Joy, you stay on, don't exit, but anyone else who's fine with convenient number estimating, go ahead and you can peel off and I'll go over this a little bit more. Give me just 1 second, Joy, for anyone who's sticking around to go over the convenient number estimate, just give me 1 second. I'm just writing something down so I don't forget where we left off. Okay. All right, so Sarah, Joy, Kay, did you guys want to go through the convenient number estimating also? Joy, I will with you for sure. I'm just making sure anyone else who didn't want to stick around, they know. That's good. That's all right. So Sarah, if you're good, you can go ahead and peel off and end the thing. And Sylvia, did you want to stick around to cover the convenient number estimating? All right. Well, I'll go ahead. You know what I'm going to do, Sylvia? Just because we're still recording, I want to stop recording this, but I don't want to lose the recording. Let me see something.